For these next few lessons that we're going to be doing, we're going to be looking at probability distributions. And we're going to talk about what does that look like, and we're going to expand that on what we did with probability and odds. So one of the basically idea is we're going to take a look at this idea of what is a probability distribution, and we're going to spend a lot of time talking about what does discrete probability mean and a continuous probability, and we're going to compare them a little bit. And hopefully when we do this, you'll see that we have a diagram or a visual to understand that. So we're going to be able to define that a distribution is binomial. All right, and we're going to talk about what that means during the lesson. We're going to be able to figure out the probability of that distribution and the expected value, or what's the expected outcome of that distribution. So that's kind of the goal of this lesson, and pretty well throughout the next few lessons as we do it. So what does a binomial distribution look like? And it's based on the idea of success and failure. So if I'm looking at this, I'm looking at probability of rolling doubles 2 times in 6 trials. Well, a binomial distribution has independent events. And we learned in the last unit that independent events are not connected. The probability stays the same throughout. So we have a definite success probability P, and we have a definitely success or a failure probability of Q. And we're going to talk about what that looks like as a picture. So the first thing we have to understand is what is success? Well, what are we looking for? All right. Well, what we're looking for here is we're rolling doubles. That's our success. All right. Now, the number of times we do that, that's going to be part of our calculations. While our failure is simply not rolling doubles. So it's the opposite, or the complement. All right. So in this case, we're looking at rolling 2 in 6 trials. That's how many successes we'll have. Well, in this case, if we had 2 successes, here we're going to have 4 failures in 6 trials to add up to the 6. So that hopefully that kind of makes sense as we're going forward. So that's kind of the first thing, is we have to know what we're looking for. And once we know what we're looking for, it helps us with the other idea. So what is the probabilities? The trials are independent of each other. So we just talked about that up at the top. And we're looking for success or failure. So it's either going to be it happens or it doesn't happen. There's no gray area in between. There's only one calculation. So if I'm looking at defining success, well, if success is rain, well, failure is no rain. Success is a face card, failure is no face card. Picking a blue Smartie, well, I picked no blue Smartie. All right. It's black or white. Arrive on time in class? Well, we don't arrive on time in class. That's a failure. Okay. So it has to be one thing or the other moving forward. Okay. All right. So push pause if you need to copy that down, or we're going to go on to the next page. All right. So the next thing we're going to figure out is how do we calculate? And this will look a little different, but I think if we looked at in 3 small chunks, I think this formula will make sense. So our big variable is going to be x, and that's going to be like our let statements that we did back in grade 9. We're going to let x represent a variable. Well, for a binomial is we're going to let x represent the number of successes in n trials. So if we went back to the previous question, we had 6 independent trials. All right. The probability of a little x, so this is a little x, and you'll see me write it like this, in n trials is this formula. So we can have multiple different successes. We could have 2 successes, 3 successes, 4 successes. All right. And these are the things that we're going to be able to define based on the wording. So P is the probability of success, Q is the probability of failure, N is the number of trials, and X, that little x is going to be the number of successes. The expected outcome, all right, so how many successes we normally would see is dependent on that probability times the number of trials that I do. That's what we're going to take a look at today. All right, and you'll hopefully will see over the next few examples how the connection between that. All right, so let's look at it. So we're going to use theoretical probability for our first example. When rolling dice, you're looking for sums of 7 or sums of 11. You roll the dice 8 times. So before we do that, we want to kind of define our big X. So our big X is, and I'm going to actually type this out because it's a lot easier for me to do that. All right, so our big X is the number of sums of 7 or 11 occurring in 8 trials. So that's what I have there. That's my big variable. All right. Now, the second thing we have to define is what's my P and Q? Well, if I'm looking at sums of 7 or 11, well, if I was looking at sums of 7, we know that there was, if I went back to my chart, there was six events with the sum of 7 if we went back to that chart. And there's 2 successes with sums of 11. So I know if I look at that probability would be 8 out of 36. And if you get a chance, you can reduce that fraction. We could probably divide the top and bottom by 4, I think. So 36 divided by 4 is 9. So this would be 2 out of 9. Well, the Q is the complement. Well, if I'm looking at the complement, that's going to be 7 out of 9. Not too bad. My N is the trials I'm looking at. Okay. So it really depends on what you see in the question that helps you figure out what the little x is going to be, what successes we're looking at. So this should be written down every single time as a visual. Now, what we're going to take a look at is what this formula means. That's a P, and let's see here. Yeah, that's still a Q, and minus X. So I'm going to try to break this down. This part right here is the number of combinations I can have for success. All right. So in this case, in the 8 trials that I do here, I'm going to have, say, 5 successes or 2 successes, right? So this is the number of successes that I can have. The other part of it should look like the independent probability. This is the probability of success. And this part here, that's the probability of failures. Okay, so if I went back to my question, we said, what's the probability that you roll a sum of 7 or 11 5 times in 8 trials? That's my little x. So when we go back to this, we're looking for 5 successes. Okay, so if we look at this, well, how many times did we have success? Well, in the 8 trials that I had, I chose 5 successes. That's the first part. I'm going to do these in 3 colors because you're going to see some comparison. Then I can go and say, well, what's the probability of success? Well, 2 out of 9. Well, how many successes did I have of that? I had 5 successes. Okay. And then I'm going to go to Q. Well, that's 7 out of 9. And I wonder how many failures there will be. Well, if I'm looking at this, if I had 5 successes, how many failures should I have? I should have 3. Because these 5 plus 3, that should add up to the total trials that I started with. So here, if I'm looking at this, I had 5 successes, 3 failures, which gives us the 8 trials. All right, so those should always add up to 8 for this example. All right, now the other thing that we have to be able to do is put this in our calculator. And when we put this in our calculator, I'm going to bring up, I'm going to try to bring up my calculator. So I have my calculator here, and this works for any scientific calculator. So what I can do is I can go, I'm going to find my choose button. Sorry about that. I had to figure out where my buttons were. All right. So I can do 8, and I'm going to try to bring up my app. Sorry about that. I had to find the buttons for combinations on the graphic calculator, but you can do that. So I can do 8C5 times, and I would put a bracket in. So if I was doing this, I would do 2 divided by 9, close the bracket, to the power of 5 times, open bracket, 7 divided by 9, close bracket, to the power of 3. That's the way I would think about it. I should get that answer. So if I went back now, I should be able to make an answer out of that. So round that to 3 decimal places. Okay, so that would be the answer for that question. So try doing it in one step. If you're having problems with it, we can take a look at doing that on a calculator and going from there. So there you go. So we can do that. So we try to do that in one step and then give it a go. All right. So the second question was, if I go back up, what's the probability of rolling a sum of 7 or 11 no more than 4 times? So the way that looks, all right, so no more than 4 times, we want to think about less than or equal to 4. Okay, so that's where we're going to take a look at. And one of the biggest things that makes this easier is making a table. So if I was going to do this question when there's more than one scenario, I want to do a table. And sometimes that table will help you with this information. All right, so EX is the number of successes that we're going to write down. So less than 4 are going to be these outcomes. And this will help us to build the probability, but also see some patterns with the formula to put it in. All right, and I'm going to do the first couple in different colors to show you the differences in the scenarios. So if I'm looking at that, the first part is I'm going to have 8, choose 0. So this is the number of successes that I'm looking at. Well, in this case, I have 0 successes. Well, the probability of getting those successes is the power of 0. All right. And the failure part, well, if there was 0 successes, there's got to be 8 failures. Okay. And as you build this formula, you're going to see some patterns. So if I do 8, choose 1, all right, well, this is going to be, let me do a different color. If this is 8, choose 1, this is 2 to the power 9, the power of 1. Well, that's supposed to be a 7, my fault. Well, if I have 1 success, that means I have 7 failures. So you'll see how as this one will increase by 1, this will decrease 1. Okay. 8, choose 2. 2 to the power of 9, the power of 2. 7 to the power of 9, the power of 6. All right. So what I'm going to do here is I'm going to push pause. I want you to try to write down the next two, similar to what you see there. So hopefully you got what you see there. 8, choose 3, 2 to the power 2 over 9 to the power of 3, 7 over 9 to the power of 5, right? And that's all straight multiplication. So the next thing we have to do is just evaluate those. Now, one of the things we hope to see is where the peak is of all these. Okay, so I'm going to bring back my graphing calculator here, and I'm going to try to do a couple of these so that you can see that. So I'm going to do 8, choose 4. So I have to do 8. I have to do 8. For me, the graphic calculator is a little bit of a pain. 8, choose 4 times bracket 2 to the power 9 to the power of 4 times bracket 7 to the power 9, 7 divided by 9. Oh, how do you go backwards here? There it is. 7 divided by 9 to the power of 4. All right. So 0.062. All right. I'll do one more, and then I'm going to let you guys finish the rest of the scenario. So I'm going to 8 math 8, choose 3 that I see right there times 2 divided by 9 to the power of 3 times open bracket 7 divided by 9 to the power of 5. That's exactly what that looks like. Oh, the probability is a little bit bigger, 0.175. All right, so what I'm going to do is I'm going to push pause. I'm going to put the rest of the answers in there. I want you to try to get the rest of those answers on your own, and then I'll help it. So hopefully you got those answers there for the other 3. So basically when I get my answer here is I'm just going to do the sum of these. So it's just the sum of those answers, because that all this probability is based on that scenario. So if I just add up those answers, x is less than equal to 4, It's just the sum of all the individual ones. If I did 0.134 plus 0.3006 plus 0.306 plus 0.1, I think that was 195. I'm not sure. 0.062. And it helps to put it in the calculator, right? Just saying. This was actually 175, so that we remember. All right, so if I did that, 0.983. All right, and you're going to say, well, why is that? Well, if I'm looking at these answers, if I was going to draw like a little picture of this, these would be where the majority of the successes would occur. I expect maybe to get between 1 and 2 successes from that. Well, that helps us. We're able to see that a little bit clearer when we do part C. Part C is my expected outcome. All right, so if I take my expected outcome, so if I have 8 trials and I multiply by the number of successes, the probability of success, all right, I can go 8 times 2 divided by 9. I see that I expect to have maybe roughly 1.8 successes. So to kind of summarize this question, you would expect to have 1.8 successes, which is sum of 11 or 7 and 11 in 8 trials. Well, that makes sense because if I'm looking at this as a graph, this is where the highest probability is. These are where the highest probability, 1.8, well, it's between 1 and 2. That makes sense. Okay, I'll put another therefore sentence here too. All right, I'll be able to pull that of no more than 4 successes is 0.983 because the probability of success is really low, so that means the number of trials should be low as well. I'll try to find a spot for this. Put it down here. All right, so hopefully that's giving you a little bit of a clear picture with that. All right, the hardest part is getting the right information in the formula. Once you do a table, if it's more than one outcome, it'll make it easier. All right, so I'm going to cruise along a little bit faster on this, and we'll talk a little bit about this. So, probability of Mr. Brzee seeing a police officer on the 401 on any given day is 20% during the week. He takes the 401 10 times a week. So if I'm looking at my scenario here, my big X is success. My successes on this, it's the number of times seeing a police officer on the 401 in 10 days, in total of 10 days. All right. What we also know is that success is 0.20. Now, seeing a police officer doesn't mean sometimes not a lot of success, but it is what it is. Well, my Q has to be 80% because that's the failure part. All right. And my 10 days are my independent trials. All right. So the probability stays the same. Okay. So we wanted to find that moving forward. All right. So what's the probability of seeing exactly 2 times? Well, if I was writing this out, all right, big X is equal to 2. That's my success. All right, seeing it 2 out of the 10 days. Better write a 2 in there. All right, so I know that in the 10 days, I'm going to see it twice. All right. I know the probability of success is 0.20 to the power of 2. So there's my success. And hopefully my failure should be 8 times, because these two have to add up to 10. Okay, so if I do that on my calculator, 10 choose times 0.2 to the power of 2 times 0.8 to the power of 8. All right, that is 0.302 if I round that. Okay. Well, the probability of seeing it at least 2 times. Well, we're going to look at this. So we're going to say x is greater than or equal to 2. Well, if I'm thinking about this, I could make a table out of this and say to myself, all right, x, p of x. And what happens is I would have, if I was going to do the whole table, 5, 6, 7, 8. All right. And knowing you guys are very intelligent individuals, this would be my answer. All right. So we would have to write out all those 10 answers. Now, what do you think is there's got to be an easier way, because there's 8 trials. That's a lot of calculations. Well, maybe we find the complement. So maybe we find the complement of this. Well, the complement in this case is going to be 1 minus whatever the outcome is for 0 minus the outcome for 1. Both would get you the correct answer, because we know that the total probability must equal 1. So let's keep that in our minds. All right. So what I'm going to do is I'm going to push pause here. I want you to find these 2 scenarios. All right, and then come back and check to see if that works for you. So if you did that, you would have seen that 10 choose 0 because there's 0 successes. The number of successes to the power of 0. Probability of failure, there's 10 failures. 0 plus 10 gets you that 10 trials. 1 plus 9 gets you that 10 trials. All right, so my answer is 1 minus 0.107 minus 0.268, 1 minus 0.107 minus 0.268, (62.5% of the time, I'm going to see a police officer at least 2 times. So this part was not included, but I wanted to find it because it was a lot easier. All right. All right, there we go. Okay, so hopefully you'll see some patterns with this. The only thing really changes is your P and Q. It could be something that you have to find, or you have to, they give it to you. Part C, all right, is my expected outcome. All right, so you're given that formula. And P, well, my N is 10 trials times 0.2, because that's the probability of success. Hey, I expect to see a police officer 2 out of 10 times. Okay. So I expect to see the police officer 2 times over the 10 days. So that allows for different scenarios that are happening with that. And that should drive a lot of the questions moving forward. So my success criteria for this, all right, I think I'll go, I didn't write it down, but my success criteria, if I'm looking at this, is figure out what your event actually is. So this being your success, so this part of the scenario, figure out what your P, Q, and N are, and then plug it into the equation to figure out what number of successes you're looking for. Give it a try and see how you do.